Hello and welcome, dear viewers, to another Hazeltest video. Last time around, you learned what Hazeltest is in a nutshell kind of way, and you also saw a short demonstration of how to use one of its features, the so-called load runner, to apply load to a target Hazelcast cluster. And the video ended with a question that remained sort of unanswered. And that question was, what is the content of the next video going to be? And that's the video that you're currently watching. And the load runner offered itself, of course, because it was part of the demonstration. But then again, the load runner isn't of much use, unfortunately, if you don't know how to connect it to the target Hazelcast cluster in the first place. And so, in case you've asked yourself that question, all right, that's nice and all, great feature, but how do I make it connect to the target Hazelcast cluster? Then look no further, because this video is about to tell you. And without any further ado, let's get started. You might roughly recognize what you're looking at from the last video. Again, we have a small Kubernetes cluster and a small Hazelcast cluster consisting of 2 members running on it. But this time the task is not to apply load to those members, but this time the task is simply to connect to them. There are 4 pieces of information that you'll want to specify. 2 of them are mandatory, in fact, so you have to specify them. And the other 2 are optional, but useful nonetheless. So let's cover the mandatory pieces first. And the mandatory pieces are simply to tell the application A, the name of the target Hazelcast cluster, and B, an entry point into the cluster, or even a comma-separated list of the members. Now, in order to make this example as simple as possible, I've simply gone ahead and downloaded the native application executable from Hazeltest's GitHub page. In fact, this release was done just a couple of hours ago. It's the first quote-unquote official release of Hazeltest. It's version 0.10.1, and you can simply go ahead and download whatever suits your environment, and then follow along if you so desire. So if you call the application like that, so what I've done is I've downloaded it and then of course made it executable, and if you call it like that without anything configured, it will tell you pretty quickly that something's missing, and it's the hset cluster environment variable in this case. So let's specify that, and in here you'll want to specify the name of the target Hazelcast cluster. In my case, it's Hazelcast platform. So let's try that again. And again, the application fails fast and tells you to please specify the hset members variable. And that's the second mandatory piece of configuration information that you have to specify. And that sort of makes sense because right now, in the command that we invoked just now, the application doesn't know yet how to actually connect to that target Hazelcast cluster. It only knows how it's called, right? So this can be a comma-separated list of IP addresses or even host names of Hazelcast cluster members, or it can be, at the very least, an entry point into the Hazelcast cluster, such as host name or IP address of a load balancer that points you to this Hazelcast cluster. And I'm going to go for the latter because I'm running Hazelcast on Kubernetes and I have exposed both members using a node port type service. So in my case, I'm just going to go ahead and provide the IP address of the Kubernetes cluster's VM plus the little node port, and that's 30080. And then try to run the application again, and this time, no error message, hooray! Instead, we get a whole bunch of log messages essentially stating that the application is now doing its thing. So that's the 2 mandatory pieces of information that you'll want to provide. Let's now go for the optional ones. You can find the optional properties by simply invoking --help on the application itself. And indeed, there's 2 of them, config file and use unisocket client. And we'll get to this one in a moment. Let's start with the config file. Because here's the thing, the application comes with a default, of course, for the load it generates, but chances are that you'll want to tailor that at some point to your specific use case. And Yeah, there's a whole bunch of stuff you can configure, of course, and you don't have to configure all of that in your custom configuration file. Instead, it's sufficient to provide really only the properties that you truly wish to overwrite, and leave leave the rest at the default values, which are baked right into the source code. Short example, if you take a look at that, this looks a lot shorter than the default config.yaml file of the application itself. In fact, I've disabled everything except the Pokédex runner. Actually, let's go ahead and disable that as well, so you can see the effects this has on the application more easily. And so let me point the configuration to that file, custom-config.yaml. And now, as you can see, the application behavior is entirely different. We've disabled everything, and now the application just sits there and does nothing except waste a bunch of CPU cycles, perhaps. And yeah, I know load runner is specified with a blank here, and here it's camel case. That's already addressed in the branch of the feature that I'm currently working on. So let's go to the configuration file again and enable that. And in order to drive home the point, let me apply or overwrite another property. So the Pokédex runner is down here in the map tests section, and for example, say you wanted to use the Pokédex runner, to use 10 maps, 20 maps rather than 10. So you could simply, go ahead and specify that to be 20. And that's all you have to do to override that, and then you can sort of see that it's using 20 maps in total rather than 10. Or in fact, you could see that, yeah, in fact there it is. Look, 0 to 19. That's quite a lot of logging to sift through, but it's right there. In fact, short side note, you may have noticed this is all in JSON, and you may have wondered why this is the case. Well, a lot of corporations use log aggregation platforms such as Splunk in order to, index their log files and then make them searchable. And it turns out these log aggregation platforms can work with JSON really, really nicely. And if you provide it in JSON, i.e., nicely structured login messages, then the indexer component will recognize it and automatically index each log message into its database accordingly. And that makes it really, really convenient to then, search it and build diagrams and draw reports and stuff like that. And that would be a lot more inconvenient and a lot more difficult if this were sort of less structured. So that's the reason the application logs its stuff in JSON. So for the other one, you remember there were two. Let's again view the help file, and the other one is called use Unisocket client. And this one, this is an interesting one as well, because sometimes your Hazeltest instance will not be able to access or to connect to the target Hazelcast members directly. Sometimes the target Hazelcast members will simply sit in a different network, and you'll have to go through a load balancer in order to access them. And in this case, you'll want to tell the application to please use the Unisocket client for the Hazelcast client, because by default, it uses the Hazelcast client in smart routing mode. And the underlying design assumption of the smart routing mode is that the client can directly connect to all Hazelcast members. And so if you don't specify that in network scenarios where you can't do that, it doesn't really hurt either, except it will give you a lot of, error messages in the logs. And this sort of hides the information that's actually relevant. And so in these cases, you'll want to specify use Unisocket client equals true. So in this case, that won't actually do anything in the logs because I'm inside the same VM, and the way the network is set up here means that these IPs here are actually reachable, which is very convenient. But in the next section, you're going to see a use case in which you actually need to set this to true. So another use case for connecting to the target Hazelcast cluster, I'm on the aforementioned feature branch just now. Let me check out main. And the other use case for connecting to a target Hazelcast cluster is, well, what you're currently looking at, really. You're in an IDE, you got the repository checked out, and you want to iterate quickly over a configuration file before, say, deploying it via Helm chart. Because iterating via a Helm chart deployment is a little bit slower than iterating via this little play button over here. And so you might want to do that in the IDE itself. Or, for example, say you want to actually debug the application and understand how it works. And in these cases, you'll want to configure access to the target Hazelcast cluster as well, of course. And so let's take a look at how to do that. Previously, you saw 4 configuration properties in total. 2 mandatory, 2 optional, and as you can see nothing really because the configuration I've prepared for this little demo is gone. Okay, that's convenient, but it's not a problem because let's simply do it on the fly. So same thing, if you start the application the first time, whoops, that was the test actually. Test is green, hooray. So once the application has compiled and you start it, it will again, tell you that you have to specify HZ cluster and so on. And let's modify the run configuration so it can connect to the target Hazelcast cluster. So what I like to do is it called the little machine that could or the little VM that could? The little VM that could, okay. The little VM that could. What I like to do is provide the name of the target Kubernetes cluster or the target VM in order to distinguish the different run configurations. And now, of course, you'll want to specify the environment variables accordingly. It's HZ cluster is the first one. So again, that's Hazelcast platform, and the other one is called HZ_members. And that's a little bit of typing as well, 44.128, and that's 30.080. So now if you run that again, then it will, once it's compiled, it will go ahead and connect to that target Hazelcast cluster. And this is actually a case where the Hazelcast client embedded in the application cannot directly connect to those cluster internal IP addresses, right? And so in this case, there's a whole bunch of error messages. And this is of course inconvenient if you want to spot actual errors. And so in such a case, you'll want to go ahead, edit this once again, and provide a program argument. In this case, it's use unisocket client equals true. And what this will do is it will go through the IP address that we just provided, which is the IP address of the VM, and connect to one of the target Hazelcast members. And this connection is sticky. And the unisocket mode doesn't assume that the other members, or even this particular member, is directly reachable if it went ahead and tried to invoke that IP address directly. And the unisocket mode, really, that's another side note. The unisocket mode isn't really fit for production use, in my opinion, because of that connection stickiness. So as soon as the connection is lost to that one Hazelcast cluster member that it initially connected to, it will try to iterate through these IP addresses right there. And of course, that's a futile attempt because it can't reach them. That's the reason why you use the unisocket mode in the first place. But in Hazelcast version 5.4, that's right around the corner, actually, Hazelcast provided a property that allows you to skip the IP-based retries and attempt a retry via the endpoint that was initially provided. And the endpoint that was initially provided is, of course, this one. I think it's still not as good as the, not as fault tolerant, you might say, as the smart reading mode, but at least you can skip the iteration over these IP addresses. Right, side note end. And this is, yeah, that's the 4 configuration properties that you can use to connect to the Hazelcast cluster, or to provide a custom configuration file and to configure whether or not to use the Unisocket mode. Finally, a short note on Hazeltest's Helm chart, because this Helm chart is by far the most convenient way to use and configure Hazeltest. And let's just go through it very quickly, because of course, now that you know about those 4 configuration properties, you'll immediately recognize them in here. We got the 2 mandatory ones here in the env section, hset cluster and hset members, and of course they are YAMLed into the deployment specification with the corresponding environment variables. And then we got the 2 optional startup arguments, config file and use Unisocket client. Use Unisocket client equals false is the application internal default as well. I've only provided that here, so viewers of this Helm chart immediately see that, oh, there is a property called use Unisocket client, and you know, I can use it to change the application behavior. So if you wish to use that Helm chart, then you may find this repository useful. It's on my GitHub profile as well. It's simply called Hazeltest-charts. And if you guessed that it contains Hazeltest charts, then you guessed correctly. Congratulations. But it does so in a way that makes it convenient for you to work with them, because the gh-pages branch contains the charts in such a way that your Helm OCI can actually work with it. Now, this is a non-OCI repository, of course. Newer versions of Helm also support querying Helm charts and, in fact, you know, pulling and pushing and managing Helm charts as OCI artifacts. That's a functionality not offered by GitHub, however. So this is still the legacy format, you know, with the index.yaml and the Helm charts provided as tgz files. And there's information on how to use those Helm charts here in the README. So you can simply go ahead and, you know, add that repo and do a Helm repo update and all the usual Helm commands, and then you reward yourself with a cookie. All right, so now you know how to connect your Hazeltest instance to the target Hazelcast cluster. You also know how to specify that you wish the application to use the Unisocket mode for the embedded Hazelcast client, and as a little bonus, you also learned how to override the application internal load creation defaults. And so there isn't much more to say for this video, except thanks for watching and see you next time.